All right, welcome to a really late night video for the JNCIE-SP. It's almost 10 o'clock, but we're going to try to do at least a half-hour video. Okay, so last video we were working on IGPs. Okay, so now we're working on authentication for IGPs. Let's open up the notes folder and make a new note for the new video. Okay. So we're still working on our first goal here, and that is to configure the IGP. Okay, so I can delete these MTU T-shooting goals. Okay, and last video I explained how you can be aware of what your source address is when you create remote sessions to devices and use that source address to your advantage without losing access. You can make big configurations to the devices, such as changing the entire IGP configuration and not losing access. So let's take a look at router 3 just via console, because I don't remember how far I got with that. Okay, so it looks like on router 3, deleted all of ISIS, but I didn't set up OSPF. I wanted to switch it back over to OSPF so we can run through OSPF authentication first, and then look at ISIS authentication next. So you can see on router 4, I already do have that set up for OSPF. Yep, so the idea is to change router 3 to run on OSPF as well. And we'll do that in a manner that would be done in a production environment using a jump server. You can see I'm already in. So set configure private, set protocols, OSPF, area 000. Okay, so that should be enough. We'll see some OSPF routes populating in the table now, namely the route for the loopback address on router 4. I do think that's the only one. No, we're also going to see the route for the link to router 2 here, and we're also going to see the route here for router 1. So we're going to get 3 routes learned via OSPF in the table of router 3, the loopback address, the link to router 2, and the link to router 1. So let's see if I was correct. So yep, it looks like I see 2. Let's filter it out to make it easier to look. Oops, so it looks like there's an extra one. Oh, okay. Yeah, this is just the multicast address used to send out those hello packets. So technically I was right, or technically I wasn't right, whichever way you want to look at it. But as far as the routes we received from router 4. So via interface 001, we did receive 3 routes. Yeah, and this one we didn't receive. It's just a part of having OSPF enabled. So I was correct that we would be receiving 3 routes from router 4. So let's now configure router 2. Oops, and router 2 looks like it might not have SSH set up on it. Okay, so we've got SSH enabled, but we don't have a user account with a password. Okay, so I'll make a new user account. All right. So now I'll be able to log in from the Ubuntu Docker guest. Oh, one thing to notice too is I had been logging in from router 1. We're going to need to log in from the Ubuntu Docker guest. Okay, the other thing to notice is that I'm logged into the IP address of the loopback interface. So if I were to delete my IGP configuration now, I would lose access to the device because this would no longer be advertised and it would no longer show up in the router 1 routing table. So I'm going to demonstrate that with a commit confirmed. So in order to do a commit confirmed, I'll need to use configure exclusive. And I'll do a delete protocols ISIS. I'll do a commit confirmed 1. And then I'll hit the enter key 10 times. I think this is the best strategy when you're doing commit confirm to put an artificial delay before you hit commit. Because as we saw in the previous video, once you do a commit confirmed, it can take a little bit of time for the routing information to update. So you might be able to sneak in that extra commit if you're used to doing it too fast. And then you permanently made that change, even though you might not have wanted to. You will not save yourself from cutting off your own legs if you issue the final commit after commit confirmed too quickly. So a good remedy for that though is go enter and then go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then do a commit. And you can see my commit was rejected. My 10 enters didn't do anything. I cut off my legs. This is the moment where we can all pause and say, oh crap. And if you're on the job, you would likely need to fill out some sort of report or something that you caused an outage, especially in a service provider environments, because of course, if the customer is paying for service, you got to provide them with that service. So you got to report the outages you caused. But the good news is if you are doing commit configure exclusive, with a confirmed 1, you only need to put down 1 minute for the duration of your outage, where you would have otherwise needed to put down hours or even a full day. The other good news about this particular outage, well, actually, never mind. What I was going to say is that there was further good news with this particular outage because it only severed management, but it would have severed customer traffic as well since we disabled the whole IGP. The good news is that we can get in and fix the device without having to roll out a person to the site, or without having to use out-of-band management. We can still use in-band management because we can connect through the directly connected route on router 1 or router 3 or router 4. They all have directly connected routes. So I'm kind of surprised that it hasn't rolled back yet. Let's do a Control-C on this. Okay, yeah, I'm pretty surprised it hasn't rolled back yet. Last time we did this, I don't think it had the same issues that it's having now. Ah, there we go. So now we're back in business. Commit was not confirmed, rollback complete. So now I can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I've got my 10 prompts back, but it's still going to, yep, and it's no longer going to be there. So I can do an exit, and I'll do a show system, rollback 2. Let's do a rollback 1. Oh, okay. I guess it's just not showing up here. But anyways, we can see just how valuable that command is, because we prevented ourselves from losing the legs, and we caused a outage that lasted 1 minute instead of hours or days. All right, so let's do it the right way. So in order to do it the right way, we're going to need to log in using the proper source address so that we don't lose our EXIF. And then even this, you need to do in a maintenance window, because even though you're doing it in a way so that your terminal is not interrupted, the traffic's still going to be interrupted. So it needs to be pre-planned in advance, and all your customers using this traffic need to be notified. Okay, so let's do a SSH again, but we're going to be more aware of our source address and not just use a default source address from the Ubuntu Docker guest. Or sorry, we're actually going to be SSHing from router 1. So to do that, we'll need to log into router 1 first. We can use the Radius account because router 1 has public key authentication on it for that account, so we can just use that. And now we can log into router 2. Oh, but we will need to figure out which IP to use for the source address. Okay, so now we can do SSH via router 1. Perfect. Oops, connection refused. That's interesting. Let's take another look at router 2 and see if we can figure out why that connection might be refused. Oh, and we can actually just use the account I was using before. Yep, because this is on there. I won't have to authenticate. Oops, but that is for router 1. And it needs to do that for router 2. There we go. All right, so we've got connection refused. That's interesting. So we do have a firewall filter on here, and it looks like that filter is going to only allow traffic with this source address. So let's see where that is applied. Okay, so this one is not applied, so it's not going to be the source of our problems. And this one is not applied either, so that's not going to be the source of the problem. So you think just that, okay, never mind. So that's just the name of the term. The name of the filter itself is local_ACL. Okay, and this one is applied. It's applied to loopback 0. So you can see I was not able to log into loopback 0 because connection was refused. But it's interesting that I wasn't allowed to do that for loopback 0 because I wasn't logging into loopback 0 on run 1. Now you can see on runner on guest dash 1, I am able to log in without any issues, but the source address that I'm using does match this ACL. One way I can know for sure is I can use show system connections. Yep, and now I see all my established connections. Let's search for .22 since we know it's an SSH connection. So you can see, yep, so I've got a connection established to the IP on the loopback address. Let's confirm that that is the IP here. Yep, so that's the directly connected route on my loopback address. And sure enough, the IP address, and we can tell that this is where the SSH session was initiated from, since we see it's in a ephemeral port. But the thing that matters in our particular filter, and of course we could set up a filter to match additional criteria, is the source address, which we can see does match what is allowed in the filter. Okay, but it's just interesting that to me that I wasn't able to, let's see here, so show in description, type match R2. Yeah, so I mean, this makes sense to me that yes, connection would be confused, but what I don't understand is, okay, if I were connecting to a loopback 0, yeah, that would make sense that connection were refused. But this is applied, but I'm not connecting to an IP that is associated with loopback 0. I'm applying to an IP associated with a gigabit Ethernet port. So why is this ACL preventing me from connecting to that if this ACL is not applied to that point of entry? Let's see if removing this will allow me to enter. Okay, so we've removed the ACL from LO0 that was preventing remote access from a source IP not specified in the ACL. So let's see if that now allows access in that manner. Okay, yeah, and you see I'm let right in. So really interesting that even though I'm not connecting to the loopback, I'm connecting to a gigabit Ethernet interface, I still can't log in due to the ACL on an interface not associated with where I'm logging into. That's really interesting to me because it just seems like it's perhaps like overreaching. Um, so it wouldn't really behave the way I expect it to behave, unfortunately. But let's continue on with those changes. So we already deleted OSPF. Or sorry, we deleted, oh, we actually didn't do any of that. So let's do that now. Yep, because we did a commit confirm and we did not hit the second confirm. In fact, we were not able to since we lost our legs. So we weren't able to make any configurations because we were not able to confirm the commit confirmed. So it rolled back to configurations automatically under 1 minute. But that's really good news because it cut off our legs. So it reduced our outage time. Okay, so this will completely get rid of ISIS. Not done yet. We'll need to configure OSPF. All right, now we're good to go. We're going to learn a lot more OSPF routes that we did before. I won't count them out specifically just because there's going to be, I think, a few. Yep, so there's now 5 routes. It's a bit too many for me to worry about individually. So let's, in fact, I'm starting to feel it, which is good news because I'm kind of up a little bit late right now. So let's stop the video for now. And when we come back, we'll just have one more router to configure, and then we can set up authentication, tear it all down again, set up OSPF, look at verification, tear it down, set up IPv6, look at authentication, and then tear it all down one final time, set up IP. Actually, at that point, we will be done because ISIS does not use Internet Protocol, IP. It uses ISO, so we won't need to handle IPv6 and IPv4 differently for ISIS because it in fact uses neither. It uses ISO addresses instead. So thanks for watching, and I'll see you in the next video.